Hello everyone. Welcome to Algorithm Edu-Space YouTube channel. Today we are diving into a topic that feels like it's straight out of a spy movie, but it's happening in real life. Car and scooter hacking using RF hacking techniques. As our vehicles become smarter and more connected, they also become more vulnerable to attacks that were once unimaginable. In this video, we are not just showing you how it's done. We are going to explain how it works, why it matters, and what we can do about it. Let's break it down. Radio frequency hacking involves capturing, analyzing, and replaying radio signals that devices use to communicate wirelessly. Everything from your garage door remote, wireless headphones, RFID cars to vehicle key fobs. They all operate over specific frequencies. RF hacking uses tools to interact with those frequencies, often without needing physical access. Think of it like listening in on a conversation between your car and its key, and then mimicking that conversation later. Modern cars and scooters rely heavily on wireless communication, from unlocking doors to starting engines remotely. The convenience is great, but it introduces risk. If someone can intercept or manipulate those wireless signals, they could gain unauthorized access to the vehicle. For manufacturers and cybersecurity professionals, understanding radio frequency vulnerabilities is critical to building safer vehicles. RF hacking exposes flaws that traditional car diagnostics might overlook. Yes, it's not just theory. Many vehicles, especially older or lower end models, use static codes in their key fobs. These codes don't change with each press, which makes them vulnerable to replay attacks. An attacker can simply record the unlock signal when you press the button and then replay it later to open your car or scooter without ever touching the original remote. Electric scooters that use mobile apps or Bluetooth signals can be tricked using similar techniques depending on their security level. Devices like Flipper Zero, which is a compact, user-friendly device that can capture and replay RFID or NFC or IR signals, which is great for beginners and quick attacks. But for advanced signal analysis and broader frequency manipulation, we hackers use devices like HackRF1, a software-defined radio that allows full control over a wide range of frequencies. These tools are not very affordable but still legal to buy and used by security researchers around the world. But in the wrong hands, they can always be used for malicious purposes. The key idea is simple. Wireless signals carry commands, and if those commands are not encrypted or constantly changing, they can be intercepted and reused. Many cars still use outdated radio frequency protocols that don't implement rolling code systems, where each signal is different and synced with the car. With radio frequency hacking, we can sniff the airways of these signals, decode them, and then replay or even modify them. This process involves understanding modulation types like ASK or FSK. Depending on decoding patterns and reverse engineering the data structure, we can achieve this. At scale, radio frequency hacking can go far beyond stealing a vehicle. Imagine attackers cloning RFID badges to access government buildings, intercepting wireless police communications, or disabling vehicle fleets with jamming or spoofing attacks. Radio frequency vulnerabilities can be exploited for surveillance, theft, or even terrorism. It's also already recognized as a national security concern in many countries, and governments now are funding research to detect and prevent RF-based attacks. There have been several real world cases. For example, in 2015, researchers remotely hacked a Jeep, disabling its brakes and steering via its wireless connection. In 2019, Tesla's Model S was hacked using a key fob signal replay attack using its cryptographic flaw. In Europe, organized crime rings used relay attacks to silently steal high end cars parked in the driveways. Rental e-scooter networks have been hijacked using custom radio frequency signals to unlock or disable entire fleets. These are not isolated incidents. They are global and they are growing. The good news, these attacks can be prevented if manufacturers and users take proper steps like implementing rolling code systems for all radio frequency communications or using frequency hopping and encryption to make the signal interception harder, incorporating radio frequency fingerprinting to detect fake signals, and educating users to avoid clicking remotes in their public areas. These kind of things can help mitigate this risk. For manufacturers, frequent firmware updates and security audits are essential. And for consumers, using Faraday pouches and multi-factor authentication for vehicles is a simple but effective step. So that's the big picture. Radio frequency hacking is real, it's growing, and it's no longer just for tech savvy hackers. Tools like Flipper Zero and HackRF 1 have made it accessible to anyone curious enough to explore. But with awareness and responsible innovation, we can use this knowledge to improve security and not break it. The next section, we will show you live demonstrations, how these tools interact with vehicles and what it looks like in action. Remember, this is for educational purposes only. Never test these techniques without permission, and let's continue in the demo. Now we are at a place where we have access to an electric scooter which can be manipulated for its remote by using the Flipper Zero, a device which is quite popular these days. Now we are trying to record the signal which is to be sent to the EV, and for this, because I am present quite near to the device, it is going to be activated quite soon. I have come like around 100 or 200 meters away from the vehicle, and now I'm going to record this particular thing. Once this recording has been started, then I will actually take not the keys but this Flipper Zero towards the electric vehicle, and I'm going to test it if at all it is going to start or not. So let us try this. So guys, this is a car and the keys are here, but I'm going to unlock it with this flipper 0. I am putting the car keys here. You can see I'm not touching it, but still if I just try it, you can see I am giving a signal. You can see it got locked, and if at all we try, I can't open it. But now if I can unlock it, the car keys are still here. Now the car is unlocked and you can see. Now I am going to lock it once again. Now you can see. So it is locked. As soon as I unlock it once again, so this is about hacking a car and opening its doors without any keys by using a device called Flipper 0, which can be used for hacking. And the car keys are still here, guys. Hello guys, welcome back again for this session of hacking into scooters and cars using the radio signals from hacking technology. Now we in the previous session we have done the same hacking using Flipper 0, which is a hacking device quite popular in the hacking market. But now we have tried unlocking the same scooter with the same remote, but instead of using a device called Flipper 0, I am using a device which is called as HackRF. HackRF is an SDR, which is software defined radio. It is created by a person called Michael Osman from Great Scott Gadgets. Now I have this antenna which is used for receiving the signal from this remote, and also now because I already captured the signal, I'm going to replay it or I'm going to transmit it, and now this scooter should get unlocked by the signal. I'm not going to use this particular thing. Let's say I'm going to put it aside, and instead of using Flipper 0, I'm putting this also aside. I'm just going to unlock it with the signal I've already captured, which is connected to this Flipper HackRF. Okay, so now I already captured the unlock signal. So let's first lock this. So now if I play this, you can observe it should get locked. You can see. Now it is locked. Let us try unlocking it with another signal. Now you can still see I'm not touching the keys, but if you can observe, it should get unlocked. Now it is unlocked. So now we have seen locking and unlocking. Let's start the scooter. So now if I play the start signal, you can actually see what happens. Now this scooter is ready to be taken for a ride. Now I call my one of my students to actually take it for a ride. Ankit, please. Now this scooter is ready for taking it for a ride. Let's see. And one advantage of electric scooters is that it doesn't even give a sound. So it's quite easy for us to rock. That is where we security professionals come in to provide security for it. Now for the sake of understanding what I have done and how I have done this hacking of electric scooter using HackRF instead of Flipper 0, I have also did the screen recording part so that you can have a look at what is the software that I have used and how this software is being connected to the hardware, and to understand this integration process. Now, if you can observe my screen, you can actually see three different files which look like the data files, which are having zeros and ones on their file icon. They are called the data files. And then we have one thing called rx.grc, which is you can say receiver.grc, which is a grc file. What is this grc? GNU Radio Companion is the tool which I have used, and its file extension is grc. I also have tx.grc, which is used for transmission. And this grc functions with Python, which is basically a simple Python file. So we have rx.python and tx.python as well. We are not going to create the Python file. Once we start working with the drag and drop features of this GRC tool, automatically Python files are created and we will be running this Python code to actually work with the hardware of this particular concept. So now let us see what it is. So this tool which you are going to see now, when I open this rx.grc, this tool is called as GRC, GNU Radio Companion. And this GNU Radio Companion is purely an electronics signal handling software which is for radio frequencies. When combined with some kind of radio frequency device like SDR, software defined radios, you can get the proper output. Now here I have certain details like Osmocon source and frequency sync, file sync. There are a lot of things. Ultimately, I will be giving you reference for what exactly these things are and how you can learn these things right from the creator of this particular HackRF, which is Michael Osman from Great Scott Gadgets. The link for this particular thing will be given in the description. So now if you observe, I've created certain things and I've actually made some changes in the whole thing. What exactly we're trying to do here is we are taking the input signal from the device and capturing it using HackRF. So that is the reason it is called as receiver.grc. And this rx.grc, the source is HackRF1. There are a lot of things like sampling rate, sampling values, frequencies, lot of things which will be anyhow covered in Michael Osman's course. So if at all you see, I'm taking a source which is the signal and then I'm passing it through a frequency sync to visualize it, and then saving. Also I'm going to save this into a file. Now if you look at it, I am going to now open a file and it is going to contain the Python code for this. So this Python code is not written by me. It is purely automatically generated by GRC tool itself based on what I am dragging and dropping and what I am saving. So it's a 187, approximately 200 lines of code which is purely auto generated. Now we can also see the same thing for transmission as well, which is a little more complex when compared to the receiving. Here all you can see is I'm taking a file source which is basically the signal captured, and then I'm actually passing it through a throttle and the frequency sync, and at the same time passing it through time sync as well to see the graph and visualize what exactly I'm sending. Here the frequency sync and the time sync are going to be two different graphs which indicate the signal graph, and there is also going to be one more thing which is Osmocom sync, through which I am transmitting this from the hardware so that the device which I'm actually expecting it to receive, it is going to receive it from HackRF. Now we can see the Python code for this, which is quite similar to receiving, and this is also auto generated. You can see it is also somewhere around 200 lines of code approximately. This is around 250 to 40 lines of code. Now if at all we look, I have already captured some signals. I spoke about these data signals, right? We can see this data as a spectrum and look at the binary values. If I say I want to look at the lock signal, let me just reduce the power a little bit. The minimum power I'm going to reduce it. Now if you look at it, the signal can be easily visualized. The color gradient is quite good, ambient enough for our vision. Now we can see somewhere the data bits have started, the zeros and ones, the binary data. You can see how data is being represented here. It's a sequence or series of zeros and ones which are being transmitted as a command inside the radio frequency signal itself. Now the unlocking file also contains similar kind of signal, not exactly same, but still unlocking can also contain similar kind of signal. Let us just go through that as well. Somewhere the signal should be starting. You can see the signal is quite here. The more we pass through it, we can actually see the signal. So we can see here the signal is started and it is quite similar to what we have seen previously. Not exactly same because the data for locking this scooter is different and unlocking is different. So the data will be different but quite similar. You can find a lot of similarities between both the codes. Let us also have a look at the start signal. This is also very similar to the previous two signals that we have seen. Now let us understand, once this is done, we are going to understand how I transmitted what exactly we have done. So already you people know that my HackRF through USB cable, it is connected to my laptop, and there is also one antenna which is ready to transmit or receive. Now I'm going to change the file source, because now I'm not going to capture it because I've already done it. I'm just going to show how I'm going to transmit. So let's start with the start signal, kg start, which is going to be the starting of the vehicle, which is used to start the vehicle. If I run this, you can see it actually opens a graph which shows one kind of a peak which is rising and dropping. So this kind of a peak which is dropping, it's a continuous signal. By the way, this is a spot signal that I'm sending in a particular frequency, which is 433 megahertz frequency. Now you can see this is actually going to keep running continuously until and unless I stop it. Let's say if I want to send a lock signal, this also looks very similar, but the data file changes. That's the only thing. Now you can also visualize the signal down in the continuous signal and also the waveform. Let me try zooming it. So basically this is the signal which is actually going. As long as our signal is being popped up, it increases its amplitude and size, which informs that the signal is working. We can go the same with even unlock signal as well. You can see in the down graph that the signal is being popped up. So I hope I've given a clear idea about this particular thing. Again, an interesting topic. What is a jammer? Let's begin with the basics. An RF jammer or a radio frequency jammer is a device that deliberately emits radio signals on the same frequency band used by the target device with the intention of disrupting or blocking communication. In essence, jamming is a form of electronic interference, flooding the airwaves so legitimate signals cannot get through. Radio frequency jammers can range from simple handheld tools that block 433 MHz or 2.4 GHz bands to advanced military grade systems capable of targeting GPS, GSM, Wi-Fi or Bluetooth simultaneously. Their design depends on the frequency range being jammed, the modulation being used by the target, the power of the jamming signal, and the type of jamming, which we will explore shortly. A jammer functions by transmitting noise or modulated signals on the same frequency and timing as the victim's communication channel. There are several types of jamming techniques. 1. Constant jamming. This type of jamming emits continuous RF energy on a given frequency. This prevents the receiver from detecting any meaningful signal. It is simple but inefficient in terms of power usage. Second type of jamming, which is deceptive jamming. The jammer transmits signals that mimic the legitimate protocol to confuse the receiver. This is more advanced and potentially capable of injecting false commands. The third type is spot jamming. This jammer targets a specific narrowband frequency like 433.92 MHz. This is very useful when the attacker knows the precise channel. The fourth type of jamming is sweep jamming or barrage jamming. This sweeps across multiple frequencies rapidly or jams multiple channels at once. This is ideal against frequency hopping systems or broad spectrum devices. In automobile keyless systems, most remotes operate in narrow radio frequency bands like 315 MHz, 433 MHz or 868 MHz depending on the region where we are trying it, which makes spot jamming a popular technique. Can we create jammers using devices like Flipper 0 or HackRF1? Short answer is yes, to an extent. Let's break it down. When it comes to device like Flipper 0, it has a sub gigahertz frequency transceiver which can transmit and receive in bands like 315, 433 and 868 megahertz as discussed previously. While it cannot output high power continuous jamming signals, it can still send repetitive noise bursts or repeated protocol packets to interfere with the receiver. It also has transmit spam modes feature for basic denial of service on low power systems. Limited by hardware, output power and regulatory firmware restrictions, it can still be used for jamming purposes. Coming to HackRF1 kind of a device, it's a half duplex software defined radio capable of operating from 1 MHz to 6 GHz frequencies. It can transmit custom jamming waveforms, it can replay recorded noise, or even sweep or jam selected bands using tools like GNU Radio Companion or Q Spectrum Analyzer with HackRF Sweep or SDR Angel or RF Katana. There are multiple tools like this. So while Flipper 0 is a good for low cost experiment and interference experiments, HackRF1 is more powerful research grade tool for building and analyzing real jamming systems, including targeted role jam setups. So why is this jammer crucial in hacking automobiles using role jam attack? Now here's where it all comes together. The role jam attack, first demonstrated by a security researcher Sami Kamker, combines RF jamming with replay attacks to bypass rolling code systems in modern vehicles. Here's how it works. When a victim presses their key fob, the attacker uses a jammer to block the signal from reaching the vehicle. Simultaneously, the attacker's device, which is using SDR or Flipper, can capture and store the valid code transmitted by the fob. The victim thinks the car is locked, but it isn't because jammer blocked it. The attacker replays the captured code later to unlock the vehicle. Some advanced versions even store multiple codes to defeat basic anti-replay protection. Without a jammer, would this work? The vehicle would receive the signal because there is no jammer and it would invalidate the rolling code immediately. So the replay attack would fail. So the jammer plays a crucial role in preventing the code from reaching the vehicle, ensuring the rolling code remains usable for later and creating the illusion of normal behavior to the victim. In essence, jamming is what keeps the gate open for the attacker. Without it, the replay window closes and instantly it is going to fail our attack. To conclude, radio frequency jammers are powerful tools which are used in security research and penetration testing, especially in the automotive sector. While they are legally restricted in many countries due to their potential for abuse, understanding how they work is essential for building resilient vehicle systems. Tools like Flipper 0 and HackRF1 allow researchers to simulate these attacks in controlled environments, identify weaknesses in vehicle RF systems, and work toward developing countermeasures such as jamming detection, stronger cryptographic synchronization, secondary authentication like pin to drive or biometric checks. As always, the goal is not just to exploit, but to educate, harden, and secure the systems we use every day. Now we are going to start the jammer. It's not working. See, when the jammer is actually running, even if I try to lock it or unlock it, none of the buttons work. But as soon as I stop the jammer, it keeps working back again.
Hello viewers, I am Lokesh. I am from Algorithm Edu-Space Private Limited. In this video, we discussed about automobile hacking like cars and electrical scooters. Personally, from my side, I enjoyed a lot while making this video. Me and my team put a lot of time and effort to make it a success. I hope you also get the same feeling while watching this video. Hope you enjoyed a lot. Thank you for watching.
Hello everyone, my name is Fayyaz and I work for Algorithm Edu-Space Private Limited. We have come up with this video about how radio frequency plays an important role in today's automobile industry. It was quite a good experience for me to work with such a wonderful team, and one of my contribution is that I am the editor of this video, and in this video you saw the practical demonstrations, and I hope you really like this video and do share your thoughts in the comment section.
Hello everyone, I am Ankit. I am working for Algorithm Edu-Space Private Limited. I am here to share my experience when I am working for this video. In this video, we have learned many things like how jammers work, how we can hack automobiles, and how radio frequencies work. In this video, I have learned many things while working, and we have lots of fun. Not only working, we have days and nights for this video, and every day we work, we have learned many new things. First of all, we thought like jam signals can be only done by binaries, that mean only zeros and ones. Later we have discovered hex gives us a better jamming signal when compared to binary signals, and there are many more other things which were discussed in the video. I am very glad to be a part of this crew. Thank you.
Hello everyone, I'm Pooja Verma working for Algorithm Edu-Space Private Limited. So I'm super excited to share my experience on the project car and electrical scooter hacking using HackRF. So we had a lot of fun doing this project. We almost spent a lot of time here doing this project. So I learned a lot of things and I gained skills, and also I learned teamwork. So thank you. Please like, share and drop a comment.